neuropeptide levels, neuropeptide Y levels in the brain. Are they directly proportional to ghrelin levels or indirectly proportional? So, in other words, when ghrelin levels go down, what happens to neuropeptide Y levels in the brain? So it's directly proportional. So ghrelin levels go down, neuropeptide Y levels go down. In other words, you're not hungry anymore, right? What I find, and this is really where we left off, the coolest part of this, and it has to do with negative feedback that we talked about at the beginning of the semester, is how the intestine feeds back on the stomach. Let me just talk about this very generally at first. If food is leaving the stomach, we call it chyme at this point. If chyme is leaving the stomach, which is really a bunch of fluid that has a bunch of good stuff in it, right? Peptides and sugars and lipids and stuff like that. If that stuff is leaving and going into the small intestine, then why does the stomach need to keep working? The answer is it doesn't. So what happens is there's a negative feedback from the small intestine to the stomach to say stop working because everything is here now. And the way that works is quite complicated, but also, in my opinion, quite beautiful. So we have a series of, once again, unicellular endocrine glands, just like we saw in the stomach. In the stomach, what did we call collectively these unicellular endocrine glands? We call them what cells? Starts with a G. Very good. We call them gastroendocrine cells. We call these enteroendocrine cells because enteric is in reference to stomach. So you have these enteroendocrine cells now that are lining the stomach that respond to the presence of things that are coming into the they line the duodenum of the small intestine. And they respond to things coming from the stomach into the small intestine, like lipids, carbs, fatty acids too, and proton. And when those chemicals stimulate these cells crank out things like CCK, GIP, and secretin. All of these hormones go back to the stomach and inhibit it. What really do they inhibit? So globally the stomach's inhibited? CNS, right? They inhibit the enteric nervous system. The cells of the enteric nervous system are inhibited, and therefore the stomach action is downregulated. Now, that might not seem really cool to you, but the reason I think it's cool is because of this. The thing that stimulates CCK to be released is primarily the presence of lipids, but virtually everything really stimulates it. So in other words, let's say lipids, proteins, and carbohydrates all stimulate the release of CCK. But the main thing is fat. Lipid is the main stimulator, but all food stuff stimulates the release of CCK. So CCK, when it senses food stuff in the small intestine, it does negative feedback on the stomach and says shut down. But here's where it gets cool. CCK also runs off to your pancreas and says secrete all your digestive enzymes into the small intestine. Why? Because I just sensed that in the small intestine is all the stuff you need to digest. So it goes to the pancreas and says dump all your digestive enzymes because all the food stuff is here now. It does a little more than that. We'll talk about that in a second. GIP is primarily responsive, and we're going to talk about another one as well that's similar to GIP. It's called GLP-1. So GIP and GLP-1, they're both primarily responsive to carbs. And so when they sense carbs, they do the negative feedback on the stomach. But then they also run off to the pancreas. And what do you think they tell the pancreas to spit into your blood? Very good, insulin. Think about how cool this is.